Here I'm going to go over Project 10, which is Interpretability with Supervised Learning-Based Trading Strategy. And what I'm going to cover is some of the background and overview of the project. I'm going to discuss the progress that we've made this semester and talk about some of the next steps for the project that we're going to do in the coming months. Start, let's just give a background of the project. So what we originally were tasked with doing was creating interpretability tools for a set of Bitcoin data, which was input into a machine learning model and had a signal outcome, which was a buy or sell. And one of the issues with machine learning is when you're using complex models, you run into the black box issue where you don't know why the model is making predictions that it did because it's very complicated. So to solve this, you have to use interpretability tools. So you can see below, these are some of the tools we used. The main four we used are SHAP, Lime, LE5, and Daleks. And how these models work essentially is they analyze the feature importance. They tell us which features are contributing most to the outcome of the machine learning model, as in which feature has the most significant impact on what the prediction is going to be. So if we were to look at Lime, for example, on the top right, we can see that some of the biggest contributing features are the EMA 26 and the EMA 50. And you can see that those are contributing most to a sell signal, meaning that you should sell the stock. So that's how the project started, and it evolved over the course of the summer and the semester into working with different types of data. So while we originally were working with Bitcoin, we moved on to use various big blue chip stocks such as Apple. That was one of the main ones that we used, the one that we started with. And what we did with the project was we started developing our own machine learning models, which used the same parameters as the Bitcoin data and applied the model to these stocks. Our goal with this was to create a trading strategy where we can predict the price movements of the stock and determine whether we should buy or sell the stock. And after spending a lot of time on this, we wanted to take the project further to create a rating system for the stocks that we were using. Essentially, this was meant to function similar to Moody's or Morningstar, any of these big rating agencies, except instead of rating the stock using the traditional analysis they use, we wanted to rate the stock using a machine learning system. So as you can see in this image, for example, you have a company like Moody's. They'll assess a stock through various technical indicators, and they'll give it a high or low rating. Here, we're looking at Apple stock. We can see that it has a AAA rating, which is the highest rating that's given by Moody's. And our idea behind this project was to see if using machine learning and these mathematical technical indicators, we could see if the model we make can produce better ratings and better results than these big rating agencies. Our hope was to show that machine learning is a viable option for assessing the quality of stocks in all these major companies. So how we went about this project was basically we kept multiple Google Colab files where we were all able to work on the code together, edit the code together. Everyone could see what's happening in real time. And there wasn't really any assigned roles to anyone. What we had was specific goals that we wanted to meet, and we worked at those goals at the same time. It's often, doing something like creating data sets. You can see the snippet below of some of the codes we've written. It can be a big task, and often it'll require all of us contributing to accomplish it successfully. So now to go over methodology and some of the things that we did in our project. One of the big things is backtesting. So once we created our trading strategy using machine learning, we need to compare it against actual historical stock data to ensure that it's functioning accurately or to see if it can outperform historical data. So here, for example, we're looking at Apple using a 10-day short moving average and a 6-day short moving average over 5 and 10 years. And you can see the comparison between the returns from our strategy versus the actual returns. You can see that they're fairly close, but also our strategy outperforms the actual returns slightly. Now, the next important step is benchmarking. So we need to have something to compare our results to. What we're trying to do is create a system where we're getting stock ratings based on whether we should buy, hold, or sell based on the results we're getting from our model. So how we do this is we need to have something such as this here, where you can see that this is the analysis for Apple stock. You can see that analysts have given the stock, for the most part, a buy, which is a good indication. So if this stock was rated, say, this was a highly rated stock on our scale, this would be probably an A stock. We would want to compare the rating that we're getting from our model to the actual rating given by the stock, and then we would need to backtest it to see if our rating of the stock is more or less accurate than the ratings given by one of these rating agencies. We spent some time gathering data for benchmarks across various rating agencies for the stocks that we're using. For the sake of simplicity, where this is pretty much Apple throughout the entire paper. For all these graphs and charts is Apple stock. But benchmarking is something that we would have to do after we make our actual model, which is something we're still in the process of. So we need to add signals on model or features. Essentially, this is similar to what we've done in the past, where we would add additional features that would affect the outcome of the prediction, whether we should buy, sell, or hold. But since we are creating a rating system, it becomes a bit more fundamental, and we try to incorporate signals that use aspects of fundamental analysis, not just strictly looking at the numerical data. To explain that a little bit better, so we'll start off by saying that we are using a lot of the same indicators that we were using before, such as the moving average, exponential moving average, but we're also trying to add additional indicators that analysts would use to give a rating to a stock. So this is one of the ones we're trying to implement. This is just one example. We're trying to implement multiple more like this, but this one here is the Altman Z-score. So essentially, this signal uses a lot of balance sheet data. So you can see here you have all these variables. So you have the net working capital over the total assets. You have the retained earnings over total assets, earnings before interest and taxes over total assets, equity over total liabilities, and revenue over total assets. And essentially, this allows us to look into more of the fundamentals of the company to give a rating rather than just doing it strictly based off historical price data. And so what we want to essentially get out of something like an Altman score would be if it's greater than 1.8, and ideally we want it to be greater than 3.0 because what it measures is the risk of bankruptcy. And we don't want to invest in stocks that are likely to be losers, or vice versa. We could sell these stocks, and create a strategy trade around trading losers, but that would be something we would do in the future. But essentially, this measures the financial stability of the company. So that was just a very brief overview of some, like, the background of the project, some of the work we've done, just looking at some of the major assets. You can find more detail about it in the final paper that you can see here. But there's also, besides the work we've done now, there's also a lot more that we're planning on doing in the future that's essential for creating the system. So right now we're just working on adding the signals to the data sets so we have something to plug into our model. But after we do that, there's still a lot of steps taken after that. So after we have, our fully completed data set with the signals, we need to actually create the model and plug in like Apple stock into the model to see what kind of rating we get. And then we'll need to benchmark that with the ratings that we found on the rating agencies. So that's just the first step. After we do that, we will need to incorporate interpretability to test why we're getting the outcome of the model that we are, see if we need to adjust any features, maybe add new features or signals, or drop current ones. And then once we have a little bit more stability in that area of the model, we can start applying other stocks, start inputting other stocks in the models to the ratings we get, because ultimately that is what we want. Blue chip stock, there's not a lot of benefit into using this for blue chip stocks or just major stocks in general, because those are generally safe, stable. You don't necessarily need to use a machine learning model to analyze those. It would be a lot better for other types of stocks, like smaller stocks, and to see if a machine learning model can provide better ratings than a rating agency for these smaller stocks. And another option in the future would potentially be to apply this to bonds. So this model is highly customizable. Um, Even once we create the final model, make all the edits, tune it, there's always ways you can adjust it. Any trader using this model would be able to adjust it anyway for their trading strategy. You can adjust the signals, the features, the type of machine learning model implemented. There's a lot of customizability to this. So this is something that can always be adapted for the future. So that's just an overview of a little bit of the background of the project we're working on and what we're planning on doing in the future. Hopefully we'll have more in store in the coming months and have, ideally we'd like to have a functioning model by early next year.